Okay, so we're going to start our endocrine system notes. If you weren't here on Monday or Tuesday, the endocrine system slideshow is right here, and it will pop up in a tab. You also want to go to your online textbook and then type in your username, which is PNGHS01, and your password, which is Anatomy14. And we're in Chapter 8, Lesson 8.1. We're going to start here. So the first thing we did is we started the day with this TED Talk. So when you get a chance, go back and look at it. It's not specifically with the endocrine system, but it is very interesting, especially if you are a future healthcare provider. And then we started the endocrine system with the rest of this crash course that we've watched previously. And we started at minute 6. Okay, so Hank's going to tell you about that. Okay, so let's go through the notes. All right, so your objective. If you have your objective, you're either going to write it down on your objective page. Remember, your objective page is the left-hand side. We'll understand how the nervous system and endocrine systems work together to regulate body functions and maintain homeostasis. Of course, that is the purpose of most of our body systems. We'll be able to describe the anatomy, functions, and dysfunctions of glands and their hormones, and that's probably going to be the next section. All right, so on your notes page, and so how this is going to work, I'm just going to go through, and you're going to need to pause me and write down your notes, okay? So these are the functions of the endocrine system. You're going to write those on your notes page. So pause me and do that. What we're going to begin with is, so in Hank's presentation, he talked about the nervous system versus the endocrine system. He said the nervous system was like sending a text message. It's very fast. And the endocrine system is like mailing a letter, putting a stamp on a letter, writing a letter, and mailing it. And that takes longer. And that's because hormones have to go through the bloodstream and affect the target cells. And so they don't have this fast axon transmission system like the nervous system does. They have to go through the bloodstream. And so it takes them a little bit longer to affect the body, but they linger longer. So that's the difference. Endocrine system takes longer to affect the body, but it also lingers longer. Also, so this is what this says, and so you can write this down. But in your book, read page 268, the third paragraph. That's going to be here. So this is a really good explanation of that as well. So be sure you read through both of those. Hormones are chemical messengers that act on specific target cells, and so they are very cell specific. You have all these hormones floating around the bloodstream. They have access to lots of different cells, but they're only going to affect certain cells because those certain cells have certain receptors on their cell membrane. Okay, so please remember that. It's kind of like a radio signal. So you have radio signals all over the in the airwaves, but you're only going to hear the song if your radio is tuned to that certain frequency. So you're going to have hormones floating around the bloodstream, but you're only going to affect certain cells because they have that certain receptors. These are the types of glands. You have endocrine versus exocrine. We're in the endocrine system, so we're going to be talking about endocrine glands. But remember, the exocrine glands, they also they are connected to the integumentary system. All right, so the cell membrane. Let's talk about the cell membrane a little bit. The cell membrane. Let me get a new page here. So the cell membrane is made up of these phospholipid molecules. Okay, phospholipids. Hopefully you remember some of this. And it makes this bilayer. There's 2 layers of your phospholipids. And this is how your cell protects itself. Okay, so we know that lipids are fats. And they are hydrophobic. They don't like water. This is how your cell protects itself. It keeps certain things in and lets some things in and keeps other things out. That's called selective permeability. Because you have these polar heads. They're outside. They're facing the blood, facing the cytoplasm, and they like water. but you have these hydrophobic tails in the middle that don't like water. And so most things in your body are polar, they're hydrophilic, they like water. And so they're not going to be able to just come through the cell because these tails are going to repel them. Okay? So you have two types of hormones. You have hormones that are lipid hormones that are lipid soluble. And so they are hydrophobic as well. They're not charged, they're nonpolar, they're going to come straight in. Okay? And so what hormones do, they're going to come straight in, they're going to bind to the nucleus. And so they're going to go through all this stuff, and eventually they're going to mess with transcription translation, and eventually they're going to change the proteins that are made. Okay, so either increase them or decrease them or make different proteins or whatever this hormone does, but it affects what proteins are made, the products of the cell. Okay, and so these can come straight through. They are primary messengers. Okay, but most of your hormones are amino acid hormones. They are water soluble, because most things in your body are going to be water soluble. So they're water soluble, so they're not getting in because these hydrophobic tails don't like water, and they don't like things that like water. And so what they're going to have to do is they bond to a receptor. Okay, so they bond to a receptor, and that causes this cascade reaction. So this happens, and this happens, and this happens. And eventually, you're also going to have it bind to the nucleus and do some stuff to the proteins. But these are secondary messengers because they can't they can't come in. And so you have two different types of hormones. You have your primary messengers, your lipid hormones that are lipid soluble, and then you have your amino acid hormones that are not lipid soluble. Okay, so you don't have to draw that; it's just for you kind of information. But that's going to explain this next part, which is the two different types of hormones. And so on your notes, write types of hormones, and then this is going to be the rest of your page. I went ahead and did the two columns. So go ahead and pause me and write that. Underneath your objective, on your objective page, control of endocrine system, there are three different types of control. You have your neural control, which is like your epinephrine, like Hank explained. You have the nervous system that affects the glands, that affect the hormones, that go back and affect the nervous system. So that's one type of control. Hormonal control is where hormones turn glands off and on, and that's going to be mostly what we're going to be talking about. This is like the negative feedback system that we've talked about before, that we discussed in the first chapter. Then you have humoral control, which is like glucose regulation in the body. And you weren't here, but we did an activity that showed how glucose is regulated in the body, and that's humoral control. And that's on page 272 in your book if you want to go back through and look at that. This is a chapter where it is useful to be able to read diagrams. And so just like a company has a president who gives orders to the vice presidents, who give orders to the managers, your nervous system, your endocrine system does that as well. You have your hypothalamus. Your hypothalamus affects like two other glands, right? But then these other glands, this anterior pituitary for sure, affects other glands, which affect other cells. Okay, so there is this downstream effect. And so if you are a healthcare provider, if you have issues here, you may not be able to solve those issues here. You may have to come up here or come up here to solve those issues. So be sure you kind of understand where these hormones are coming from. But I do want you to draw this. This is on page 272. I do want you to draw this on the rest of your objective page. And pay attention to what stimulates and what inhibits and how those are used. Okay, how those are used and how those affect other cells. Because these kind of diagrams are going to be important for what we're going to do in a couple of days.